Good afternoon, everyone. So I have the pleasure to let you all doze off into a nice afternoon slumber after lunch. I hope I'll not bore you too much. So I'm going to talk about Upstream First, as in Upstream. That's kind of the tagline Intel and lots of other companies use for how you should do open source development properly. And the idea is everything you do with open source, you do it first in upstream. So all the hardware enabling, all the product development, whatever it is you're doing, before you ever ship this software stack to customers. So it starts with upstream and then trickles down to your product trees, to stable trees, to whatever. And there's lots and lots of talks about why this is a good idea and why this makes technical sense and why this makes business sense, kind of explaining what's the upsides. And so my personal experience, I've done lots of open source graphics at Intel, and 10 years ago, Intel open source graphics was essentially an R&D project with no customers. Just moonshot, cool idea, maybe we can earn money sometimes. And over the past few years, we got lots of customers, the team grew tremendously, and we pulled in a lot of formerly proprietary teams out of kind of the Windows world and made them do open source. And more interesting for this talk, I kind of watched them fail at it. And in my role as open source graphics maintainer in the Linux kernel, I've also seen that story unfold with lots of other companies. Open source graphics is a lot more established than 10 years ago, like with AMD, with Qualcomm. And mentoring all these teams, watching all these people, working together with them, I do find kind of the usual technical reasons for why you should do open source, why you should do upstream, are a bit unsatisfactory. Like I said, there's lots of data about like claims that it leads to better products, leads to a quicker and cheaper development, and all this stuff. And in my experience, there's a lot more blurry. So what I'm trying to do here in this talk is, obviously I've stolen all the ideas from other good people. I kind of try to explain to you folks why I think open source works fundamentally and why Upstream First is kind of the one and only way to go about this problem. We need a few fundamentals for this. First one is a tiny bit of microeconomics. Now, I know microeconomics is kind of this idealistic thing, assuming that humans are perfectly optimizing for their financial benefits all the time, which just isn't true. But there's a lot of interesting concept that, at least in the limits, if you kind of repeat something for long enough, a market of people producing stuff and consuming stuff tends to walk into that direction. And one such fundamental claim is that in a perfectly efficient market, the marginal cost of producing another copy of your product should be the price. Because if it's like lower, like companies will go bankrupt, so eventually gets higher again. And if it's higher, like other companies will enter this market and drive kind of the surplus out to zero. And the other thing is, if you apply this to software, marginal cost of software is zero. Like storing another copy of the Linux kernel costs you roughly nothing. It costs you roughly nothing to transfer it, and every 2 years it gets like cheaper. Like the price for transmitting bits is halved about every 2 years. So that's kind of one thing. The other is the open source license. This is the MIT license. I'm using that one because MIT started open source graphics like in the 80s. We're using that one. And the other thing is, it's a legal text that fits on a slide in its entirety, which is kind of impressive. But I don't want you folks to read it, so let's just black it out. There's 3 paragraphs here. First paragraph essentially says, you can use the software without limitations under 2 conditions. Second paragraph is like the first condition, so you need to keep this license text and the copyright notice and all that stuff. And the third text is the legal disclaimer, as in this stuff is not fit for any purpose, so don't choose if it blows up. And if we look at what such an open source license does fundamentally, it removes all the barriers to entry for a market. So if someone has a software product, someone else wants to enter that market and compete, all the sunk cost of developing that software, they don't have to pay it again because they can just take the source code. The without limitations, so I'm not like a lawyer, this is not legal advice and all that stuff. The without limitations is really, really broad. So this also has an implicit patent grant. So you can't go around and say, okay, this is this open source software. And later on tell the people, oh, by the way, now you need to pay for this patent. In theory, at least, I think case law is not there. No one has tried to do this. So, and there's obviously lots of shades of gray in different open source licenses with different rules. Some are a lot longer than this. Try to be more explicit. But fundamentally, what an open source license does is really it removes all the barriers to entries, all the sunken costs. Next competitor doesn't have to pay. They don't have to pay license costs. They don't have to pay patent costs and all this stuff. So what I think what open source fundamentally is and why it works, it's simply it creates an efficient software market. Efficient as in microeconomics. So it drives the price down to marginal cost, which is zero. And in theory, that's all. So in theory, we could like have a coffee break now. But in practice, what this does to you kind of produce a customer relationship is such a fundamental change in kind of the power dynamics that if you've never done this before as a team, as an engineer, as like a company, you will fail. Because there's kind of very, very, very little experience outside of open source in a highly competitive market where the product clears at a price of zero. So I want a bit to illustrate this core idea of why I think open source works, why it matters, with lots of failure stories. Because kind of the culture clash of doing business the traditional way and doing business in this open source market is huge. And I think the best way to get people to understand what's going on is with examples. Obviously, not all the details and stuff. So the first one, which is kind of entertaining if you're an experienced open source maintainer, is you get a patch or an email or something, and at the bottom there's this confidential disclaimer, as in, if this conversation is not meant for you, please delete it, otherwise we'd be angry at you with legal means. Which, yeah, is amusing if this gets sent to a public email list. And it's kind of one of these things where these culture clashes. But if you look deeper, the question is, why are big open source projects so much focused on having all the design discussions, all the review, everything in public? Generally, even internally in a company, it's generally not how you do things. You don't like do your changes and your patch review and 10,000 other people, or maybe 100,000 here at Siemens, or a few 100,000. Like, watch it live what's happening. And so if you look at kind of this communication clash of doing it in the traditional company way and doing things the open source way, we can look at the efficient market. So one of the most important things to have an efficient market is that everyone has the same information. That's why insider trading is not allowed in like stock markets. And I think that doing design discussions in private is kind of the open source equivalent of doing insider trading. Essentially trying to get like a bit of an advantage, or you might be able to get a bit of an advantage by discussing things in private, trying to influence things in private, and then go in public. And so the confidential disclaimer is not kind of the usual funny incident when people first contribute, but kind of the entire mindset of doing everything in the open is kind of a consequence of open source being a lot more competitive and really trying to have the most efficient software market that you can create. Another one that like happens with every team, like every team has an engineer or a few somewhere, where you get the very special. And maybe this is a consequence of again kind of the more corporate culture of not freely sharing information all the time. It's also generally in a company you just get one team to solve a problem, whereas if you're an open source maintainer, you see, for example, in graphics we have like 30 plus display drivers. And they all kind of solve the same problems. They all have the same problem of generally having more outputs than clock generators, generally having more scan-out engines that read stuff from memory than FIFO space, because FIFO space is expensive, costs a lot of die space, and all these things. And so if you take like an engineer who's being like the lead engineer in their team, being the only one in a huge company who solved this problem, of course they're going to assume that their solution is special because they haven't seen the other 29 other drivers that solve the exact same problem in slightly different variations. But again, there's this kind of bit of more fundamental thing here going on in open source, that there's a huge drive to avoid vendor-specific solutions. So in the kernel graphics driver, we have one standard interface for how you expose a display engine, with all the special solutions for like embedded segments, for tablets, for mobile, all that stuff. And kind of vendor differentiation in sometimes attempts to segment the markets more so you can extract more value. They're just not accepted. So again, the very specialist, yeah, at face value, it's kind of amusing. But again, the overall open source drive in lots of projects is really just to make the competitive landscape a lot tougher by making vendors more interchangeable, by standardizing their solutions a lot more, to make sure that there is no one special. And another interesting case here, and I didn't even pick this because Greg was the original keynote speaker, is this quote from Greg. Like, it's not my self-interest. It's in my self-interest to ignore your patch. Oh, that's kind of the extension of your special. The thing is, if you're an open source maintainer, and fairly often, like, your customer is the maintainer. So in graphics, the OS vendors who integrate our graphics solutions are the people who built the OS that then ships on devices. They're the maintainers. So they're telling us in the Intergraphics team how this stuff's supposed to work and what they want to see. And so when there's lots of vendors, different solutions, a maintainer tends to be somewhat overloaded depending how a project works. But they also have seen the exact same nonsense disclaimer from the email, like from every team that ever joined Upstream, or from a lot of them, and seen like tens, hundreds of engineers screw up all in similar ways. So that's kind of the first thing of how the power dynamics tends to shift, like in open source. If you're developing a solution, you tend to be somewhat at the mercy of the upstream maintainers. They tell you how this stuff is supposed to work. They tell you, no, we're not going to take your special solution. We want something that's cross-vendor, and all these things. So the way you kind of get past that bias that, oh, yes, this is another engineer from this company, I know how they work, they don't get it, is you need to work for a lot of years sometimes, building up a personal trust relationship with your maintainer to show that, yes, you do understand how this open source stuff works. That's kind of why these maintainer relationships are so important and kind of signify progress, as we've seen earlier today. It's really hot in here. I'm sorry. So if that's kind of what it takes to become effective in upstream and start to kind of push for the interests of your own vendor, the best way to fail is to rotate engineers through projects like all the time. I've seen that especially internally at Intel, where pretty much every time we mentor a new team, they don't get it. Like, they assume engineers are just interchangeable cogs. And after half a year, 1 year, once the people have started to absorb this massive culture change of how you do development, how you, in a way, do business in open source, then they get reassigned to another project, disappear for 2 years, and then you get them back. And so there's an enormous amount, and it's not just Intel, it's really just everywhere. There's an enormous amount of kind of wasted mentoring and kind of wasted on-track time that disappears if you don't kind of build up these center of excellences in understanding upstream and open source. To be able to kind of build up these long-term relationships. So what Intel has been doing for decades, I think by now, is we have the Open Source Technology Center, which has a critical mass within Intel, still a very small part of the company, and which is used somewhat as an incubator for new teams. So open source graphics started in Open Source Technology Center. And I think a year or two ago, we moved out to the hardware people because it was then established enough with the hardware division that this is how you do open source, and we're the experts, and we do it for them. Whereas before, I don't think that would have worked. So critical mass and keeping the people around is really important. Another one which is really amusing to watch if you're outside and totally not amusing if you're inside, luckily I have like both perspectives, is in big companies especially, but in general, like internal politics is really complicated. You want to do this project, so you need to have a favor there, someone needs to give up a bit of budget over there, and it's really complicated mess of how you can get on a project or a product and ship it. And so in the proprietary world, fairly often the biggest pain of making something happen is getting that internal compromise and getting buy-in from all the stakeholders and all that stuff. The companies that never done upstream, they don't even consider that maybe they should ask upstream or by extension their customers. And then they go public and it gets rejected. And like 1, 2, 3 years of development with sometimes huge teams is just not useful. So one example here, which is fortunately public, so I can talk about it, is AMD has a few years ago changed their open source, their graphics driver strategy for Linux and decided to completely switch over to an open source, fully open source stack. Graphics driver is pretty complicated. So you have a kernel driver, then you have in user space, you have drivers, you have compilers for the different standards. There's OpenGL, kind of the traditional acceleration API. There's a new standard coming out, Vulkan, which is quite a bit more low level, quite a bit more complicated to program, but with the benefit of giving you more performance potential. And so when AMD did this entire strategy and decision and figuring out how they do the plan, they decided for the OpenGL side, they're going to keep using their existing open source driver, which is already established in the Mesa 3D cross-vendor project. So there's AMD there, there's Intel there, there's lots of other drivers there. But for the Vulkan thing, because it's all new, there's nothing there. Let's just figure, well, we're going to open source. We need to write a new driver anyway, so we can make sure we have all the licenses to actually open source it. So I figured that they do a clean slate design. Completely fresh driver. Unfortunately, legal review took a lot longer than expected, as it tends to do. And they were like a full year late. So Intel had an open source Vulkan driver on the 1.0 release date in the cross-vendor infrastructure, in that Mesa 3D cross-vendor project, whereas AMD just didn't. And they always said, yeah, any moment now. And eventually, like, customers and community people got fed up and just typed an AMD Vulkan driver in the cross-vendor project, using all the existing infrastructure. And because they were reusing all that existing infrastructure, they made, essentially with like 1-2 people, and about half a year, they managed to implement and conformant and performant Vulkan driver. And that's the thing that now everyone is shipping. And the AMD has kind of a political, or internally political problem of having a project that no one wants, but still kind of the inertia behind it, and kind of the compromise between, okay, we're going to do open source, but from the traditional group, we're going to take this team, and from the open source, kind of this compromise solution. And so, yeah, a good way to file open source is if you're entirely focusing on your internal processes and totally forgetting that there's customers and upstream out there. Another good one is outright paranoia about your patents and your general all over awesome valuable IP pile. So intellectual property, the poster child of this one is Qualcomm. For their open source work, they founded an entire different company that holds none of the IP. And so all the people who are allowed to contribute, they work for a different company. So make sure that they know, never ever like accidentally give a patent grant for one of these implied patent licenses. Which works really well, as you'd expect, because they can only talk with the hardware engineers through the legal department. So, works great if you have a technical question. What the end result of that is, the kernel graphics team, so nowadays Google's Chrome OS is shipping the Upstream kernel driver. This was a kernel driver that was implemented through community people and is now co-developed by Google. So the kernel team, the lead developer of that kernel team is employed by Google because he's the maintainer of that graphics team. And in the user space, it's just outright the entire driver is reverse engineered and developed by the customer. So they're shipping a product, and because they're so paranoid, they have no control over what's happening on the software side. Another one, that one I just recently learned this story, is kind of outright denial, as in, yes, open source works, it's out there, but This only happens to the competition. And the example here is NVIDIA. I mean, they have the best graphics product. And one of the most important things they're doing, and they now at for the competitive advantage, is developer relations. They make sure that whatever workload out there exists for GPUs, for compute, for machine learning, for games, works really, really well on NVIDIA. And one example of open source that's brought up fairly often is that your customer can run the debugger and the tracer through the entire stack. So if their application crashes, and the crash happens somewhere in that huge user space driver, they can see the full backtrace, they can see what the code does, they can debug the code, and they could, in theory, like write a bug fix for it and send it to the vendor or to, well, the Upstream project if you do Upstream First, and everyone is happy. Or they can even use this to, if their performance isn't good and they have a hot loop and it's in the driver, they can see why it's a hot loop. This may be even comment what you should be doing instead, and all that stuff. And NVIDIA knows, in theory, this gives you better developer relations for a very cheap price, because the customer is doing all the work. But this doesn't happen to us. And a few months ago, at our yearly graphics conference, we had people from Valve, the game company, who are using Linux for their Steam box, and from Google, explained that, yes, they actually do this. And the NVIDIA engineers there just didn't realize that this is actually happening in real world, not just like a theoretical example. So if we take all these examples together, what we get is what I call not just customer orientation, but radical customer orientation, as in, if you're not extremely customer oriented, your customer just takes over the project. And if you kind of compare this to traditional R&D and how far away the actual customer using your software tends to be, is, at least at Intel, like this, an R&D department that does the graphics hardware and the graphics driver and all that stuff. And then there's the solution groups that makes use of that for like mobile or for servers, for compute, and whatever. Then you have the sales departments that actually sells all the chips and talks to the customer company, at least. And then you have the reverse side on the customer side, until a few groups later on you actually talk with an engineer. And if you compare this to what happens in open source, is you submit the patch for the solution to your lead engineer on the customer side, because he's the maintainer. And he's going to tell you, or they're going to tell you, whether they're okay with this solution or not. And all the things, stuff like vendor differentiation, market segmentation, patents, it's kind of all out. And usually at that point, once people planted their faces on the concrete a few times, they're starting to get really frustrated, because all the incentives that they have from the company do not match what they need to do. If you're in an R&D department, you're kind of measured by, for example, how many patents do you create? And if you create a software patent as an open source engineer, all you do is delay your product, because you can't open source your work. And so usually the frustrated sick happens that, well, but my career, like my yearly review, this is not going to make me look good. Or also with the product, how can we still ship product with this, or have a company, or have like any income when the customer like bosses us around like that? Because I mean, let's face it, no one likes selling into a highly efficient and competitive market. It's not fun. And that's kind of what open source is. So, spoiler, I'm employed, I get paid. So what are we missing? Or how does this work? And the bummer is, one thing that does actually happen is, sorry, you're not getting paid. There's no food on the table for you. So this is really not a joke. In a way, efficient market just means you have an efficient market. It doesn't mean it's actually a good outcome. One example here is a few years ago, I think by now, there was this OpenSSL Heartbleed security bug. The industry realized they're using a core piece of their infrastructure which has no maintenance and no one taking care of security bugs. And there was a bit of an industry-wide panic. But yeah, like that maintaining these developers, they didn't get paid. And this is a huge discussion in open source in general. There's tons of really popular projects out there that the developers and the maintainers simply get nothing because it's an efficient market. And the marginal cost for their product is 0. So they get nothing. And there's lots of kind of attempts at fixing this. Yeah, like I said, every once in a while there's an industry-wide panic. Someone sets up an effort to at least support the baseline stuff a bit better, and then it kind of petters out again until the next panic happens. So clearly this is not a solution, and it doesn't get anyone paid. So the next one is just be the best. I mean, this entire efficient market only works in the limit if you like play out this game for long enough. If you have the best product, you can always stay ahead and kind of sell your product for more than marginal cost. And in the graphics space, this is definitely NVIDIA. They have the best GPU, and they have the best GPU since years. There's a bit of problem with this. If you ever slip up, you have your entire company culture focused on you're the best, you are actually special, and then you need to switch to like a different market when open source kind of made inroads, at least in some segments, and then suddenly you're no longer special. So the culture clash gets even more painful. The other problem is there's a lot more people believing they're the best than who actually are, I think. So what this often boils down to is you wait for bankruptcy. And the thing is, this is not a bad strategy. Like, if your customers, if you would know that your customers take another 20 years to figure out that they could ask for open source products so that it can really boss you around, then it's much better to just write the high margin for the next 20 years than actively work towards destroying all that. Personally, I think, yeah, the problem with that, from my experience watching teams adopt to open source, is it takes you 5 to 10 years to get there, to understand the impact on how this changes your customer relationship, what the incentives for your teams, for your engineers need to be, how you interact with the customer. And that might be longer than your bank reserves. So if you miss the time when your competitors and your customers figured this out and created this efficient market, you might not have time to adapt. So assuming you have like this open source market, how do you still make money? And the thing is, you need to sell something else because you can't sell software that there's no money in that. And what Intel does, Intel sells hardware like silicon chips. And what this essentially means, my job is not R&D, as in don't really develop new stuff. What I do is I develop sales prospects, like I'm a sales engineer. I explain to the customer in really elaborate source code form how to effectively and efficiently use Intel's real product. And the trouble there is the incentive structure is all wrong. I mean, I'm still employed by an R&D group in Intel. So what I measured every year in my performance review does not actually reflect what I'm doing to get customer sales and to make sure the customer's happy and keeps buying our product. Another thing that works is you offer services. This is kind of the Red Hat business model. They're kind of selling open source, but what they're actually selling is the humans backing the support contract. So it's a service business where the product you're selling is human time. And what's also nice, kind of just looking from an individual engineer, is once you have this complementary product, you can switch around companies. So that's the part where I really like open source, and your skill set is fully transferable. So all the things I do get published, and if I go to the next company, my skill set is almost completely transferable, which is kind of nice from a job hunt perspective. And you also get like a really nice professional network that spans across companies. Now, one complementary product that lots of companies try out, which I think does not work so well, is software. So they try to have like this open source software. It's generally called the open core model. And then they have some extension software somewhere, which is the magic proprietary sauce that they're selling. And usually this has a contributor licensing agreement attached to it, so that everyone has kind of the same rights, but they have more rights. To kind of trying to reestablish this barrier to entry. This is so bad that for most companies, you're flat out not allowed to contribute to projects with CLAs. Because it's not really actually open source. You're kind of trying to have open source while not actually wanting the efficient market, and that just doesn't work. There's a recent cool internet story about, I think, Redis and the common clause, where some venture capitalists invested lots of monies and noticed a nice hockey stick growth in adoption of this open source software database, or whatever it is. And then tried to monetize it, and then realized you can't actually monetize something that sells for $0. And now they're trying to retrofit the licensing change, and lots of screaming, so that they can reestablish a market where they have an advantage that no one else can have. But yeah, capitalism kind of doesn't really work like that. So altogether, and tying back to why you should do open source, Upstream First, is because it's really hard to time market. It's really hard to figure out whether your customer, or when your customer and your competitors will figure this out and start creating this efficient competitive market. I think the one solution that works is just be first. So in those 5 to 10 years it will take you to implement the culture change internally. You need to start, because if you only start once your competitors has already completed, you're like 5 to 10 years late. And you need to revamp everything. You need to revamp like R&D, the incentives for engineering, how you plan product, no more internal plan, or a lot less internal planning, kind of development cycles, customer interaction, all that stuff massively changes. And maybe for closing, Super short summary. Yeah, open source, I think, is just an efficient market. And what this means in practice is you need to have radical customer orientation, as in either you're customer oriented or your customer takes over. You need to have some complementary non-software products so you actually earn money. You will be fighting years of culture clash, and I do think for selling product, you need to be first, or it gets really complicated. So, thanks for listening.